Static electricity. In this lesson, we're talking about the parts of the atom, neutral versus charged objects, friction, the law of electric charges, static and hair, the electrostatic series, and then sparks and lightning. How your lesson works. Text that is bold and underlined is blank on your student copy. When you see it, pause the video and copy it into your notes. Whenever a video is available, you will see the video icon. Refer to the additional resource document to find the correct video link. While you're watching the video, take a few jot notes on the main ideas that are covered. Static electricity. So you walk across the rug, reach for the doorknob, and zap, you get a shock. Or you come inside from the cold, pull off your hat, and your hair stands up everywhere. So what's going on here? What's moving around? And why does it happen more in the wintertime? So I want you to pause the video and answer these 3 questions. So what's going on here when you get shocked or when your hair stands on end? Well, we get shocked because when we walk on carpet, electrons become deposited upon us. When we touch the metal doorknob, the electrons jump, resulting in a shock. When your hair stands up on end, it's because the hair is all becoming like charged. They're all getting the exact same charge, whether it's positive or negative, and as a result, they're repelling each other. What's moving around exactly? Well, that's electrons. Electrons are the thing that move around. And why does it happen more in the winter? In the wintertime, the air is drier because there's less water in it. In summer, water in the air works to remove excess electrons. Therefore, humid air prevents electrons from building up on surfaces and then jumping from one place to another. Parts of an atom. In the middle of each atom is the nucleus. That's this guy right there. The nucleus contains 2 kinds of tiny particles, protons and neutrons. Orbiting around the nucleus are even smaller particles called electrons, and that's these gray guys right there. Electrical charges. In regards to the atom, what you need to know is that we have protons, neutrons, and electrons. Protons are positively charged, and they have a large mass, relatively speaking. Neutrons have a neutral charge, so no charge, and they're also large, relatively speaking. And then last, we have electrons around the outside that are negatively charged and have a tiny mass. It's the electrons that we're going to be focusing on today. Neutral objects. When the number of protons in an atom equals the number of electrons, the atom itself has no overall charge. It's said to be neutral. So for instance, if you have 2 electrons and 2 protons, that's like saying +2 plus -2, and that's going to be 0. That's going to be no charge. And most objects have no charge. That's good because you don't want to be getting shocked every time you do something. So most objects that you come across in everyday life are neutrally charged. Charged objects. Static electricity is the imbalance of positive and negative charges. Atoms that lose electrons have more positive charges, protons, than negative charges, electrons. They are positively charged as a result. An atom that gains electrons has more negative than positive particles. It has a negative charge overall. So if you have 2 objects, say object A and object B, and object A has 3 protons and object B has 3 protons, object A has 2 electrons and object B has 4 electrons, we would say that object A has an overall positive charge because it has more positives than negatives. You could think of it as +3 plus -2, which is equal to +1. Object B, on the other hand, is negatively charged. If you take a look at its overall charge, you're going to have +3 plus -4, which is going to equal to -1. So it has 1 more electron than a proton, therefore it's going to be negatively charged overall. Now, how do electrons move from one place to another? Well, one very common way is through friction. Friction is when 2 objects are rubbed together, and as a result, electrons may be transferred from one location to the other during this process. The more rubbing there is, the more electrons are going to move. Friction and charge buildup. Pause the video and check out the simulation and see what happens when friction increases. Law of electric charges. Law number 1, opposites attract. 2 things with opposite or different charges, so for instance, a positive and a negative, so that could be a positive and a negative, or a negative and a positive, will attract or pull towards each other. Law number 2, things with the same charge, so 2 positives or 2 negatives, will repel or push away from each other. So you have law number 1 here, where opposites attract, and law number 2, where the likes are going to repel each other. Law number 3 states that neutral objects attract both positive and negative charges. So if you have a neutral object, it's going to attract both a negative and a positive charge. So that brings us to the application of balloons sticking to walls. So why does a neutral wall attract a balloon? Well, if you charge a balloon by rubbing it on your hair, it picks up extra electrons and gains a negative charge. So the electrons go from your hair to the balloon, and the balloon becomes negatively charged. The result is that if you hold it near a neutral wall, you make the negative charges in the wall move away because like charges repel. So these negative charges here, mainly there, 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 and there, get pushed a little bit this way. Like we're talking micro distances, but it's enough to create a slightly positive front and a slightly negative inside of the wall. This slightly positive front part of the wall will create an attraction with the negative charges on the balloon, and the balloon will stick to it. Pause the video now and check out the second simulation. Static and hair. So if you slide down a slide or take off a winter hat, sometimes your hair stands up. So why do you think this happens? I want you to pause the video and I want you to write down your answer. Well, when you rub against something, electrons can jump to the other object. We talked about that earlier. This creates positive charge all around your body, including the hairs on your head. Like charges repel, and since the hairs are all positively charged, they start to repel each other so they can get as far away from each other as possible. Standing up creates the most hair-to-hair distance. So if that hair is positive and so is that one, they're going to repel each other to try to get as far away from each other as possible. Again, these hairs and these hairs are all positive, so they're trying to repel each other as well. So what you end up with is hair that's sticking up all over the place as it's trying to get as far away from other hairs as possible. An electrostatic series is an arrangement of materials based on how strongly they hold their electrons. As you go down this list, the items are more likely to hold on their electrons. These guys down here are strong, whereas these guys at the top are weaker. Materials higher on the list will give up their electrons to the ones below if rubbed together. Check your understanding. If you rub human hair and wool together, so human hair and wool, which will lose and which will gain? How about glass and foam, rubber and wool, ebonite and foam? I want you to pause the video and I want you to answer these 4 questions. Okay, so if you rub human hair and wool together, since wool has a stronger hold on the electrons will go from the human hair to the wool. So which ones will hold? We'll say wool will hold. Hair will lose. How about glass and foam? Well, since glass is higher on the list, foam is lower, we're going to say glass is going to lose, and foam is going to gain. Rubber is lower, so rubber is going to gain, and wool is going to lose. Ebonite and foam, ebonite is the lowest, so it is going to gain, and the foam is going to lose. Sparks and lightning. If there are enough positive charges on one object and enough negative charges on the surface of the other object, the electrons can jump the air gap between, causing a spark. And we see this when we touch a doorknob after rubbing our feet on carpet. This is the same thing that happens in lightning. In lightning, you get a really negative bottom part of the cloud. It's so negative compared to the positive ground down here that the electrons are able to jump from the top of the cloud to the bottom. You can also get differing charges within the cloud as well. So if you get positive sections inside the cloud, you can get lightning between the cloud as well. So we can get cloud to cloud or within the cloud itself. And that concludes our lesson on static electricity.